Hello and welcome to Networks Explained Simply. In today's video, we're focusing on understanding routers and their role in networks. Sure, you know what a router is. It's the device you have to reboot when the network stops working. But what does a router actually do? Unless you've really thought about it, it's kind of a difficult question to answer, and that's because today's routers provide a ton of extra features. Things like DNS, IP address management, Wi-Fi, firewall, network security, remote access, and lots more. But none of these features actually has anything to do with routing. So maybe the better question is, what's the primary function of a router? Let's take a look. Put simply, the primary function of a router is to provide connectivity between two or more than two separate networks. In this case, Network A and Network B. The router's job is to physically connect with both networks and to make sure that data sent from a source on one connected network can find its way to a destination on a different connected network. When a computer wants to send something to a computer on its own network, the router does not need to be involved. In this case, computer A1 can simply send the file directly to computer A3 without involving the router, because computers A1 and A3 are on the same local network. But when a computer wants to send something to a computer on a different network, however, it will need to use a router. In this case, computer A1 wants to send a file to computer B3, which is on a different network. So computer A1 will need to send that file to a router in order for it to reach computer B3. Now, we've been using this word network quite a lot already, and while you probably have a rough idea of what we mean by that, we should really make sure this is clear. For our purposes in this introductory video, let's define a network as a group of devices which are linked together for the purposes of sharing information. A network is usually defined by its boundaries, and there are really two kinds of boundaries that we mean here: physical and logical. The physical boundary is fairly easy to understand. For Wi-Fi, this is simply how far the wireless signal reaches. For cabled networks, the boundary would be the number of physical ports that are available and the cables that are connected to those ports. The logical boundary relates to IP addresses and the subnet mask. If you haven't yet mastered both of these concepts, don't worry. We will be doing a video in the future to dig into these, but for now, it's enough to understand that when any device connects to a network, the device is assigned a unique numerical network address, which we call an IP address. This network address will then be used to identify that device on the network so that the router and the other local computers can find it. One of the steps in setting up a computer network is to choose the numerical range of network addresses that will be included in that network. This range of valid addresses is what we'll call the logical boundary of the network. Here we can see that this router is connected to two networks, and that the router uses both a physical boundary, which is the router's own physical port, as well as a logical boundary, which is a range of numbers, to define each connected network. To keep things as simple as possible for this exercise, we'll just use some ranges of basic numbers. Real IP addresses will look a little bit different, but the concept is exactly the same. Notice that these ranges of numbers do not overlap. The range for network A ends at 99, while the range for network B begins at 100. It is crucially important to any router that each of its connected networks has a unique and non-overlapping range of network addresses. Why is this so important? Let's take a look at how the post office works, as an analogy. For the post office to deliver mail correctly, it's critical that each geographical area across the country has a unique postal code. This is because when a letter is sent through the post office, the destination postal code written on the outside of the envelope indicates where the letter should be sent. The sender's local post office will send the letter to the destination's local post office, based on that postal code on the outside of the envelope, and then the destination's local post office is responsible for delivering the letter to the specific destination address. It's pretty clear that this system depends upon unique postal codes, Post Office B is responsible for all destinations in Area B, which is something that every other area's post office can rely on. This means that when Post Office A has a letter for a recipient in Area B, it can just send the letter over to Post Office B and be confident that this decision is correct. Just imagine how much confusion and chaos would result if this were no longer the case and if postal codes were suddenly not unique. Well, just like your local post office, a router needs to know which networks are connected to which of its ports. There can't be any overlap between one network and another, because overlap would cause confusion, and the router would no longer be able to make decisions about where to send files. Now, you may be thinking, this doesn't really match with my understanding of routers. At home, I just have one network, and I only use it for internet access. So if routers connect to two or more networks, then why do I even need one? Well, it's important to understand that the internet itself is also a network. Sure, it's a massively scaled network and it's beyond any one person's control, but fundamentally, it is still just a network. So it follows the same rules and has the same requirements as any other. So this means that even with the most basic router set up only for internet access, your router is still connecting two separate networks, just like we've discussed here. One is your local area network, or LAN, and the other is the internet, or more likely your internet provider's public network. While we're talking about routers, there is one more important concept that we need to talk about, and that's the gateway, or default gateway. In order to understand this, it helps if we change our thinking just slightly. Instead of thinking from a high-level perspective about the network, let's think from the perspective of a specific device. We can use another analogy to help get our minds around this. Let's imagine we're working inside of a room with one door. This room is part of a larger building, and we might spend the whole day in this room, but eventually we'll need to make our way out. Once we decide to leave, that door will be our pathway to all locations outside of the room, because regardless of where we are headed, passing through that door will be the first step. So whenever we're inside this room, we can think of that door as our gateway to the outside world. Now, imagine that our room is in the lower left corner of a building, and it's time to head home for the day. This means our goal is not only to leave the room, but also to leave the entire building. But notice that something changes the moment we pass through that first door and enter the hallway. Now that we've reached the hallway, the first door is no longer our gateway. Our next objective is to leave the hallway and reach the main room of the building, which means that now our gateway is the door ahead of us at the end of the hallway. And after that, once we reach the main room, our gateway will change again to the front door, and so on until we reach our destination. So each time we use a doorway to enter a different area, our previous gateway becomes irrelevant, and we need to find a new gateway for reaching the outside world. Just to drive the point home about perspective, what if two people in different rooms both want to leave the building? We can see that initially their gateways to the outside world will be different because they're each behind a different door. But once they both reach the hallway, their gateways will be aligned, at least for a short while. Once both people exit the building, or perhaps once they exit the parking lot, or maybe exit the neighborhood, their gateways are likely to become different again, unless they're headed to the same exact destination. If you can understand this concept, then you understand the default gateway. All that remains is to replace the people and places from our analogy with devices and network addresses. In our upcoming videos, we'll build on this knowledge using the same simple approach to look at things like typical network designs, real IP addresses, special ranges of IP addresses, and the actual mechanisms we use to define the scope of a network. We'll keep all of it simple and easy to digest, so stay tuned. If you enjoyed this video and appreciate what we're doing here at Networks Explained Simply, please remember to like and comment on the video. We'd love to hear from you, and this really helps to make our videos visible for others. Also, remember to subscribe so you don't miss any of our future videos. As always, thank you so much for watching.